Okay, our lesson for today is brought to you by Exponents and Radicals. We deliver for you. So here we go. We got to remember exponents and radicals. 4 to the third power. Please do not say 4 3. Say 4 to the third. 4 times 4 times 4 is how much? 64. It is 64. As you work to evaluate these, sometimes we involve negatives. This is negative 2 to the fifth power. Does that mean it's negative 2 times negative 2 times negative 2 times negative 2 times negative 2? Or is it negative 2 times 2 times 2 times 2 times 2? Which is it, the top or the bottom? It's definitely the bottom. Okay? If it was the top, it would have to be negative 2 quantity to the fifth power. There's a difference. Okay? So just to make sure we all understand, if you were to see negative 3 squared and negative 3 quantity squared, this one's negative 3 times negative 3. That makes 9. This one's 3 squared, which is 9. Make it negative. That's negative 9. There's a difference between those. Okay? So let's compute. What's 2 times 2 times 2 times 2? 32 if you multiply that all out. And then if you attach the negative, we do get that negative 32. Negative 32 is the result. For letter C, I take negative 3 and I multiply it 3 times. Negative 3 times negative 3 is 9, times negative 3 is negative 27. 11 to the 0 power. Anything to the 0 power is 1. Why? Why? Well, isn't it interesting? I mean, we do these things. We have no idea why, do we? Completely unacceptable. We do not want to be in a situation where we don't know why it works. We must know why it works. So hone into this so you can see it, because this is going to make total sense to you. If I have x to the fifth divided by x to the fifth, if I take something and divide it by itself, what do you get? You get 1. Now let's look at it the other way. These are common bases. You subtract the exponents. So this would be x to the 0 power, wouldn't it? So if we use those two pieces of logic, it means that anything to the 0 power does in fact give me 1. That's why. We don't make anything up in mathematics. There's always reason and conjecture behind every single thing that we do. So there's always a why and an answer. And we want to be able to see that. So here we go. Let's go back to our lesson. Square root. Square root of 144 is 12. Yes, demo.
I was just curious if you wanted to have your candle pink switch to test.
I don't really care. It doesn't matter, but thank you. There we go. Boom. All right, whoever's watching. All right, cube root of negative 125. What do you multiply by itself 3 times to get 125? 5. So negative 125 would be negative 5. There's a number you can multiply together 4 times to get 81. 3. Then we have 2 cubed times 3 to the negative 2. What do you do if you have a negative exponent? Drop it to the denominator. So this is 2 cubed over 1 times 1 over 3 squared. 2 cubed is 8. And 3 squared is 9. We get 8/9 out of that deal. Please try letter I on your own. Try letter I on your own. Go. Everybody welcome Mr. Dibble. All right. Woo! Don't stay here too long. You'll start pitting out in your shirt. Good? You are. Actually, you can leave the door open, like suck in some colder air. Okay, here we go. 1/3 to the third, and then 6 squared. That's what we've got. Okay, so what's 1/3 to the third power? 1 over 27. Then 6 squared is 36. So we get 36 over 27. And 36 over 27 can be reduced. Both are divisible by 9. So you get 4/3. Next one, radicals. You want to simplify radicals? You can multiply them together. 5 times 45. What's 5 times 45? It is 225. So you get the square root of 225, which is 15. Now suppose you didn't know this, that 45 times 5 was 225. You had to find a different way of figuring it out. There's a kind of a nice way of doing this problem, different than this. And it goes like this. Square root of 5. And then I'm going to break 45 into two parts. Root of 5 and root of 9. Now watch how easy this is. What's the root of 5 times the root of 5? Root of 25, which is 5. Hey. If you get too close to it, it can sense you. So I get 5, and then the root of 9 is 3. So you can get 15. Notice in that situation, I never had to multiply 5 times 45. Multiple ways of doing the problem. I want you to do K on your own. Try to do it like I did this example. Go. Okay, root of 3 times the root of 3 times the root of 16 is what you should have. What's the root of 3 times the root of 3? 3. The root of 16 is 4, so you get 12. Notice how I didn't have to multiply out the 3 times 48. So trust me, folks, I'm not giving it to you because that's a problem on the test. I'm giving that to you so you can see different ways of navigating. I'll do one more for you so you can just kind of understand. Suppose you had something like this. Suppose you had, you're doing, say, the square root of 80 over the root of 10, okay? Well, you can just divide that up in the square root of 8 times the root of 10 over the root of 10. What happens? Those just cancel, right? Runs to the root of 8, which is just 2 roots of 2. So there's ways of navigating the roots. Flip it over the, oh wait, do we have one more there? Okay, in this last one, what if I have negatives both on the top and the bottom? What are you going to do? Yeah, move both of them. So 4 squared over 2 cubed. If you have 4 squared, we get 16. If you have 2 cubed, you get 8. So the answer is 2. The answer is 2. Any questions on that? You flip it over to the other side. As you flip over this other side, now we're going to deal with what problems are a little bit more challenging. Can I subtract those two radicals right now? I can. Okay? In order to subtract radicals, you must have radicands that are the same. So I'm going to break this up into a couple parts. What are the two numbers that multiply to 18? I got 9, and I've got 2. Now I've got the square root of 200. What's the perfect square that divides evenly into 200? What's that? 100. So I get square root of 100 times square root of 2. Notice how both of these, what is going on? It picks up my skin every time I'm a little bit closer to it. Sorry about that. So I've got the root of 2, I've got the root of 2. That's a good sign. And now I've got the square root of 9 is 3 roots of 2. Minus 10 roots of 2. That gives me negative 7 roots of 2. What's different about letter B? Cubed root. So in letter A, people tend to get this right on the test. People screw up this problem right here. Number one, they don't know what the perfect cubes are. Perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, 64. Those you've gotten used to over time. Well, you maybe haven't gotten used to the perfect cubes as much. 1 times 1 times 1 is 1. Well, what's the next perfect cube? 2 times 2 times 2 is 8. So 8's the next perfect cube. Then 3 times 3 times 3. So 27's the next one. 4 times 4 times 4. 64. 5 times 5 times 5. And then 6 times 6 times 6 is 216. 7 times 7 times 7 is 343, so on and so forth. A lot of times people only remember up to about the 125. And I'd say as long as you do that, you're fine in this class. So when I do letter B, I don't want to look at this one right there. I want to look at this one right here because I'm dealing with the perfect cubes. So what's the perfect cube that divides evenly into 16? 8. 8 goes in twice. So that's the first mistake people make. They don't grab a perfect cube, they grab a perfect square. And then I add that to 2 cube roots of, what's the perfect cube that divides evenly into 250? 125. And that goes in twice. Okay? So, as we look at this right here, I have the cube root of 8, I have the cube root of 2. The cube root of 8 is 2. And the cube root of 125 is 5 times 2 is 10. And as I add those together, you can see that I get 12 cube roots of 2. 12 cube roots of 2. So the mistake people make with this problem is they don't grab the perfect cubes, and then they don't list the cube root at the end. If you don't write that cube root, say it's a 2-point problem, I take off a half a point. Okay? Got to make sure you write your index up there. So let's try a couple problems that you probably know how to do. I want you to try letter C on your own, and I want you to try letter D on your own. Lots of people had success with those. It seemed like they already knew how to do them. You give them a shot. Well, okay, I multiply. 3 times 4 is the 12, and then y to the second times y to the fifth is y to the seventh. So that's my problem right there. Letter D, move the exponents to where they're not. And so in this situation, I'm going to bring a to the fifth to the bottom. It's going to join the a to the eighth. The b to the seventh moves to the top, and b to the third moves to the bottom. So if we have negative exponents, move them to where they're not. Now, if we're multiplying these, we add the exponents. We get a to the 13th in the bottom. And then b to the 7th over b to the 3rd. If you're dividing, you subtract the exponents. You get b to the 4th. So your final answer is b to the 4th over a to the 13th. A lot of people seem to don't remember what to do when with exponents. I've got a little chart that kind of helps people along with that. If you look at example E, we're going to use this chart. This is a lot of stuff going on. The first thing I'm going to point out is that this 3xy to the fourth is the same thing as just 3xy to the fourth. The fact that it has parentheses around it doesn't really matter, okay? This is what it is. But the next part here, we have 2x to the fourth, y cubed, cubed. What would you do first in trying to simplify this expression? Yeah, I heard Alex say exponent. We're going to deal with this cubed one up there. What do I do with the 2? Do I take 2 times 3, or do I take 2 to the third power? 2 to the third power. What is 2 to the third power? It is 8. What do I do the exponents? Do I take 4 times 3, or 4 to the third, or do I take 4 plus 3? Which one is it? 4 times 3, so it's x to the 12. And then y to the third, again, I multiply, I get y to the 9th. So I want to pause there to show you. Notice that our first operation was a power. We were taking it to the third power. So what did we do to the coefficient? The coefficient was your 2. We raised it to the power. So when your operation is exponents, just do that with the coefficient. But what do you do to the exponents? We don't take the exponents to a power. We do one step lower. We multiply. Now our operation is multiplication. So what do we do to our coefficients? Our coefficients, we do exactly what we're told. We multiply. And when we multiply, we get 24. What do we do to our exponents? We add, because that is one step less than the multiplication. So I x to the 13th and y to the 13th. Now some people wonder, how does it work with the addition piece? Suppose I had 5x to the 4th plus 8x to the 4th. That makes 13x to the 4th. Notice how I added the coefficients and I did nothing to the exponents. That's exactly how it's laid out. See that? There you go. Okay, we're going to skip letter I, but we need to do the others. Letter F looks tough. What do you want to do first for letter F? Okay, I heard something about the exponents. It's just we have 4 fans going on. So which exponent do you want to deal with there, kiddo?
I was going to say make a negative 1 positive first, but what do you do inside first?
This one? You can do that. So Evie is pointing out that you could take the x to the negative third and move it up. And that is totally legitimate. What I find that a lot of people want to do is they want to deal with that negative first. And that negative, if you see negative, it means we flip everything. Okay? So I'm going to flip everything in here. I have 2x to the negative third, y to the 4th on top. And on the bottom, I have x to the third, y to the third. And so what I used up in that situation was just that negative. Now we're going to do what Evie suggested. She said, let's deal with this negative 3 right there. So I'm going to deal with the x to the negative 3 power. It's got to move from the numerator to the denominator. So my denominator is going to be, instead of x to the third, what's it going to become? X to the 6th. So she's 100% right. Okay, that negative 3 is going to come down and make that an x to the 6th. Now, what can we simplify in here? Your y to the 4th over y to the 3rd is just going to become y. And then we square that to get 4y squared over x to the 12th. Whoop. What's different about G? I suppose are fractions. Does that kind of bother you? I mean, let's admit it, we're not very big fans of fractions, are we? No. And that's pretty normal to not really like fractions. So here's what the excellent mathematicians do. When they struggle with a problem, they just make an easier problem. What if the problem looked like this? What if it looked like negative 2a to the third times 5a to the fourth? If it looked like that, would you know what to do? Yeah, you'd say easy problem, right? So let's just do the same thing here that we do up there. Negative 2 times 5 is negative 10. And then in this situation, you would just add the exponents. So here, let's just add the exponents. 3/4 plus 3/2. How do I add fractions? Common denominators. So instead of 3/2, I'll write that as 6/4. And 3/4 plus 6/4 is 9/4. That's the answer. Letter H looks even more challenging. But again, I'm going to say, well, if you don't like the fraction exponent, then let's just make an easier problem. Suppose it was like that. Okay? Now would you know what to do? You'd say, well, yeah, it's easy, Mr. Gens. What do you do with the exponents? You just multiply. So let's multiply these exponents. 8 times 3/2. If you're multiplying by a fraction, easy. Multiply by the top, divide by the bottom. 8 times 3 is 24, divided by 2 is 12. And then 6, you can do the opposite too. You can divide by the bottom and then multiply by the top. 6 divided by 2 is 3, multiplied by 3 is 9. But then we got this tough part right here. We don't take 4 times 3/2, we actually take 4 to the 3/2 power, don't we? 4 to the 3/2. And that's a learning piece that you maybe have forgotten from last year. The fact is, if you have 4 to the 3/2 power, that is the same thing as 4 cubed square root. And the reason why is if you have a fractional exponent like that, you take this and you drop it out front. That's what square root means. So if you had 8 to the 5/3 power, that would mean 8 to the 5th, and then you take the cubed root of that. That's what it means. You take this and you drop it out front in a radical. So let's figure out what this is. What's 4 cubed? And what's the square root of 64? 8. So I get 8 out of that. So if we drop back to our page right here, this is 8. Okay, last little bit. See if we can simplify that one on your own. Try to come up with anything to simplify that expression. It involves a few variables. See what you come up with. Okay, pause, see where you got, okay? I first asked myself, is a to the 4th a perfect square? It is, so a to the 4th goes here. Is b to the 7th a perfect square? It's not, so I reduce the power by 1. Is b to the 6th a perfect square? Yeah, so I put a b to the 6th right here. So a to the 4th, b to the 6th is not the same as that, so I have to put the other b over here. Notice now I maintained equality. I have an a to the 4th, and a b 6 times b is b to the 7th. Now I can reduce it by taking the square root. What times what is a to the 4th? A squared. What times what is b to the 6th? B cubed. Root of b. Next one, this situation, I have a cube root. So we're going to separate into 2 cube root pieces. Is x to the fourth a perfect cube? Nope, so I reduce it by 1. Is x cubed a perfect cube? Yeah, so I got x cubed. What am I missing over here? X. Is y to the 8th a perfect cube? Nope. Y to the 7th? Nope. Y to the 6th? Yes. So what am I missing over here? Y squared. So now you can take that cubed root and get x y squared times the cubed root of x y squared. Our last example for the day, sometimes as you're simplifying radicals, sometimes the easiest thing to do is simply multiply the two radicals together and see what you get. So in this situation, you've got w v to the 4th and w to the 5th v to the 8th. When I multiply those together, I get w to what? 6th and v to the 12th. Well, those are both perfect squares. So this simplifies quite easily to w to the 3rd times v to the 6th. And that's your result. If you look at your homework, you can see that from this page, you guys were working on the intervals and inequalities yesterday. As you flip it over, now we have exponents and radicals, exponents and radicals. So for today, you would stop at 1.3, algebraic expressions. The video tomorrow is going to be on algebraic expressions. So on Monday, you can work on any of the assignments that you have, ask questions, do whatever, but that will be time for you to kind of get caught up on some things. Make sure you solidified some of your learning. So that's what I have for you. I'm going to sign up from this video.